Welcome to Think Tank Tutor. Today we are going to talk about reactions of organic compounds and bond fission. Reactions of organic compounds are mainly grouped into four categories: elimination reaction, substitution reaction, rearrangement reaction, and addition reaction. Now let's move deep on each type of reaction. With elimination reaction, during elimination reaction, usually there is formation of unsaturation, means double bond or triple bond in the product. Example, we have alcohol which is converted to alkene. Basic example, we have propanol which is converted to propene plus water. Mean there is elimination of water and there is formation of double bond in the product. On substitution reaction, it involves replacement of atom or group of atoms for another atom or group of atoms. Example, we have alkyl halide plus dilute alkaline solution, which will give us alcohol and salt. On this example, we have bromopropan react with sodium hydroxide to give propanol and sodium bromide. As you see, hydroxyl group substitute bromide group and will lead to the formation of alcohol, and the bromide will react with that sodium to get sodium bromide salt. Other reaction is rearrangement reaction. In rearrangement, a molecule undergoes reorganization of its constituent parts. Example, we have hydrolysis of alkenes to ketones. We have the alkyne react with water in presence of sulfuric acid and mercury sulfate at 60 Celsius, which will give enol, and that enol rearrange into ketone group, as you see on that reaction. Other reaction is addition reaction. Often in this reaction there is removal of double bond or triple bond. It is just the opposite of elimination reaction. Example, we have hydrogenation of alkenes to alkanes. You see, we have propene which is converted to propan. In addition reaction, there is also three kinds of reactions. We have free radical addition, electrophilic addition, and nucleophilic addition. In free radical addition, there is addition of chemical species called radicals. These radicals result from homolytic bond fission, where there is equal sharing of electron from covalent bond after it is broken down. Example, we have halogenation of alkenes in the presence of ultraviolet ray or ultraviolet light. On the other hand, we have electrophilic addition. This occurs when electrophile is the first chemical species involved in the reaction. Mean electrophile is attacked by nucleophile or lone pair. We see it later on next video on reaction mechanism. Then nucleophilic addition. This takes place when nucleophile attack on region of low electron density, especially in carbonyl compound. Example, we have addition of hydrogen cyanide on ketone or aldehyde. We will see different this reaction and their mechanism in the next video. Bond fission. Bond fission is the breaking down of covalent bond into two or more species or fragments. This can occur in two ways. It can occur as heterolytic bond fission or homolytic bond fission. Later we discuss on those two cases. When a bond breaks such that one fragment takes away both electrons of the bond, leaving the other fragment with empty orbital, this kind of cleavage or bond fission is called heterolytic bond fission. It occurs when the bond broken was between atoms of different electronegativity. Remember, electronegativity is a tendency of atom to attract bonded electron in a covalent bond. So when there is different electronegativity, means that one with high electronegativity will attract or lose electron from covalent bond and leave that one with low electronegativity with empty orbital. And this will result to the formation of nucleophile and electrophile, as you see the representation of heterolytic bond cleavage or bond fission on the video. Then nucleophile is electron-rich species which is attacked by electron-deficient species. That electron-deficient species is electrophile, and the nucleophile can be charged or neutral species. Example of charged nucleophile, we have chloride ion, bromide ion. While in neutral species, we have ammonium, we have water, and others. On neutral nucleophile, it is just referring to the Lewis base, or nucleophile refers to Lewis base. Electrophile. Electrophile is an electron deficient species which attacks a region of high electron density and makes bond. It can be charged or a neutral species, as we have already seen on nucleophile. Charged electrophile means it is always charged positively because there is lack of electron which have been taken to nucleophile. We have ethyl ion and we have hydrogen ion. On neutral electrophile, we have aluminium, chloride, and others. Then, when a bond breaks so that each fragment takes away one of electrons of the bond, the process is called homolytic bond fission. Homolytic bond fission produces fragments with unpaired electron called radicals. In that case, there is equal sharing of electron from covalent bond, as covalent bond is formed by two electrons. One electron will move on one fragment and another electron will move on other fragment, and there will be no formation of charged species. Rather, there is formation of fragments or species with one electron, which are those called radicals. So next time we will look on how those different electrophile, nucleophile, and radicals interact in a reaction by referring to the reaction mechanism.